Hi, welcome to another class with Physics Anchor, and today we'll be solving more from JAMB past questions under the topic motion. So today we have two questions on the board, and I must tell you that these two questions are just to refresh your mind. They're actually simple questions. So number one, okay, we have a motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. A motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. Calculate the retardation. Of course, in the past videos, I've explained that retardation simply means deceleration, and it's just the opposite of what? Acceleration. So I've explained that. So let's just analyze the question and solve it straight up. So brought to rest means that what? If it's actually being brought to rest, it means that the speed, final speed is 0 meter per second square. So this is what really we can explain this to be. Okay, so this is how it will look like. So it was actually brought to rest from a speed. If this is the velocity, if this is the time, so it means that this motor vehicle is brought to rest from a speed from, so the initial speed is actually 15, which is u equals to 15 meter per second. So it's now brought to rest, meaning that what? It is brought to what? 0, which is the final speed now. And that actually took place for about what? 20 seconds. In other words, this from here to here is actually what? 20 seconds. So they want us to calculate the retardation. So time is actually 20 seconds. So the retardation that they want us to calculate is still A, acceleration symbol. Is still what you are going to use, which is going to be your A. The only thing is that what? When A represents retardation or deceleration, your answer will be what? Negative. And you're going to see that right now. So we use the formula V equals to U plus AT. Our V is 0, our U is 15 plus our A, our T is what? 20. So that will be that we have, if we bring this 15, or let's bring this one here, let's just say 0 equals to 15 plus 20A. So if we bring 20A, that will be minus 20A equals to 15. That will be A equals to 15 minus, that's over 20, and that will be minus 3 over 4 if we use 5 to actually cut, and that will give us minus 0.75. Yes, that will be 75. And what we calculated is as deceleration, which is retardation, is going to be in what? Meter per second square, the same unit as acceleration. So the answer is just going to be negative. But when you check your option here, you can see that they did not put negative there. So you just look for, I've told you the essence of this negative sign is just to show that it is retardation and not acceleration. So it's just the opposite of acceleration. So our correct option here is A, which is what? 0.75 meter per second square. So that's the solution to number 1. Let's get to the solution to number 2. So in the second question, the question may seem long, but it is a very simple question. Okay, the figure below, that's the figure, I've put the figure here, shows velocity time graph of a car which starts from rest. So this car starts from rest. They did not indicate anything on the graph. So let us begin to indicate. It starts from rest, meaning that what? From 0 speed. So it starts from rest, okay, and is accelerated uniformly at the rate of 3 meters per second. So our acceleration, let's just write acceleration, okay, equals to 3 meters per second squared, okay, for 5 seconds. Okay, that's for t, which is 5 seconds, meaning that what? This is the line representing the acceleration. So acceleration took place for 5 seconds. So we can indicate it there. It attains a velocity which is maintained for 1 minute. So it attained this velocity. We don't know the velocity. Okay, it attained that velocity and maintain that velocity. You will see the line here that is constant. It maintain it for 1 minute. And what is that 1 minute? 1 minute is actually 60 seconds. That's, if you convert it to seconds, it's going to be 1 times 60, that's 60 seconds. So this is where the constant speed, okay, that it maintain last. So that's 60 seconds should be what? Here. But because this is already 5, okay, so this will be 5 plus the 60, okay, that it took. You know, it took about 60 seconds for this line. So this place will be 65, okay. The car is then brought to rest by a uniform retardation. So this is it. So it's decelerated. It is brought to rest by a uniform retardation after another 3 seconds. So this one from here to here took about what, 3 seconds. So 3 plus 65, that will be 68. So that's the correct way to represent it. Okay. Now they want us to calculate the total distance covered. So try to refresh your mind on velocity time graph. When you want to calculate the total distance covered or distance covered, area under the graph is the one that will give you the distance covered. When you look at the shape of this graph, you see that what? The shape of this graph is actually a trapezium, okay? This trapezium was shape, okay? And in trapezium, you know that what? We label this side as A, we label this side as B, that's this line, and we label this height as what? Height. So we do not know the velocity, which will be our height. So let's use the first information to calculate it. Don't forget that what the body starts from rest, meter per seconds. So we can say V equals to U plus AT, and that will be V equals to U, which is what? 0 plus acceleration is actually what? 3, and as at that time for the acceleration, T was actually 5 seconds. So that will be what? 5. That means our velocity is what? 15 meter per second. So the velocity here that is attained is actually 15. So for us to calculate the area now, we can begin to list out. We know that the distance, rather, for us to calculate the total distance, we say total distance now equals the area of trapezium, okay? Area of this trapezium, the area under the graph, okay? Area of the trapezium. And what is the area formula for the area of trapezium? That's half A plus B bracket height. So in this case now, our A is this length. Look at this length. That length is actually what? 60, okay? That's 60 seconds. So our A is 60. Our B is actually the whole length from 0 to this place, which is what? 68. And our height is actually from here to here, which you can read out. That's from 0 to what? This, which is what? 15. So putting that in the formula now, we have half. Our A is what? 60. Our B is 68. And then our height is what? 15. So 60 plus 68 will give me 128. That will be half times 128 times 15. Okay. Half times 128 will give me 64 times 15. So let's multiply 64 times 15. That will be 64 bracket 10 plus 5. I don't want to use calculator. I just want to use some mathematics breakdown. That's 64 times 10 will give me 640 plus 64 times 5. That will be easier for me to multiply. 0, 2, 30. That will be 320. So 640 plus 320, 0, 6, 9. That will be 960. And its distance, so that will be 960 meters. Let's go in and check our option. So you can see our correct option is what? D. That is what? 960 meters. Okay. This is just mathematical breakdown. It's not part of. So if you have access to your calculator in your own exam, just simply do 64 times 15. That will give your what? 960 directly. Okay. I'm just doing this because I'm not using calculator. So I hope you have a good understanding of what we have just done in these 2 questions. So try to share out this video with other students around you. Hit on the notification bell, share, like, comment, subscribe, and keep studying for your examination. I wish you all the very best in your exam. Bye for now.